What's good, code milkers? Today we have longest common subsequence. Given two strings, text 1 and text 2, return the length of their longest common subsequence. So a subsequence of a string is a new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining characters. So an example here is that ACE is a subsequence of A, B, C, D, E, while A, E, C is not. And that's because if it's out of order, it does not count as a subsequence. It has to be in the same order as the original strings. A common subsequence of two strings is a subsequence that is common to both strings. So if we look down here at our first example, we have text 1 is A, B, C, D, E, text 2 is A, C, E, and the longest common subsequence is A, C, E, because it must be in the same exact order. So A, C, E, it can't be E, C, A. Length is 3, so return 3. Then we have this example with text 1 is ABC, text 2 is ABC. That one's going to be 3 because they're the exact same strings. So the whole string is a subsequence of the other string. And then this one, A, B, C, and D, E, F, they have no letters in common and not even in the same order. So there's no common subsequence. We return 0. This is a dynamic programming question. I'm kind of new to dynamic programming. I haven't used that often, so I was doing a lot of studying today trying to figure out how to do this problem. I did find a great kind of mental model for it, which helped make my algorithm. So I'm going to link that video in the description so you can watch that because he does an amazing job explaining this problem. But I'll go through my solution and kind of how I thought of it, and then you can watch his to get a broader mental model of it. So we have our function here, longest common subsequence, and takes 2 parameters, 2 strings. Then in here, I have a matrix creator. Now this is just something that creates a 2-dimensional array, so an array of subarrays. And I use this to make a table of current subsequences at a given index of the string. So basically, the height of it, of the matrix, so the rows, are indicative of text 2's length, and the columns are indicative of text 1's length. Basically, you go one index at a time, and if the two have an equivalent letter, that means that we can increase the subsequence by 1. So we look at the previous subsequence length, which can be found 1 row above and 1 column to the left, and then we add 1 to that. So basically we're going through the table, and then whatever our last element is in the table in the last subarray, that is our largest and longest subsequence. So this is just creating a 2-dimensional array. Next, we create that 2-dimensional array, and then here in this for loop, this is where the magic happens. So we're starting at 0, of course, which is our first letter of text 2. And for each of those letters, we're going to check if any given letter in text 1 is similar to that one. And we will increase the longest common subsequence accordingly. Or if it's not, we will fill in the space in the table with the max between the element to the top of it and the element to the left of it. So using this, we can determine, eventually going diagonally across the table and landing at our final element, we can determine what the longest common subsequence is. So I'm going to console log here what M looks like after all the iterations, so you can see what it kind of creates, like the table visualization. So here, A, B, C, D, E, and A, C, E. Imagine at the top here that right here under the D, this is an empty string column, and then right here in this row, this is representing an empty string column as well. So going down, we have the 3 letters of text 2, and going across, we have the 5 letters of text 1. Now, of course, we have no longest common subsequence for the first row because it's all either an empty string or a single letter. For each of these, it's 0 because there's no longest common subsequence between an empty string and a single letter. Now, next, right here, this is indicative of index 0, 1. 0, 0, which is A and A. So we look to the element to the top left of it, which is 0. We add 1 to it because now we can increase our longest common subsequence because we have a matching letter in each index. We go across here, there's no matching letters. We don't increment, we just do the max of the previous element and the top element. Then we come down to the second row here, which is the C row. And at the second index of the first string, which is right here, and we go down to the C row, we have a match. So we look to the top left element here of it, and it's 1, so we do 1 plus 1, gives us 2. We keep incrementing, we keep reassigning each element after it to the max if it's not an exact match between the 2 elements. And then finally we get to this row, which is the E row, and at the final element we have a match between E and E, which then gives us 3. So we return 3. That's as well as I can explain it at this point without going into a ton more detail. As I said, the person I link in the video description does a really, really good job at describing it. And he also has a whiteboard so you can really see the visual of it. Yeah, the runtime is actually better than this. I just forgot to unconsole log, so it was on average about 30% earlier. Yeah, well, hope this helped. Have a good one.